We got our first taste of transformations with reflection. Let's move on to the next transformation we're going to be looking at, vertical stretch compression. From the definition, we see that, now I'm just going to alter our notes slightly. It should be when the absolute value of A. Now when the absolute value of A is greater than 1, then the graph is vertically stretched by a factor of A. But when the absolute value of A is less than 1, we can say it two ways. This way really doesn't make much sense, and I'll show you why. The graph is vertically stretched by a factor of A. It is correct to say that. But visually what we'll see though is the graph is actually vertically compressed by a factor of 1 over A. So allow me to begin. I want to transform y is equal to x squared, which is the graph provided, into a brand new parabola, y is equal to 1/2 x squared. And since, what do we see here? Well, we see that the coefficient of A is 1/2. So the absolute of A is 1/2. Now recall that absolute value is just really the distance away something is from 0. How far is 1/2 away from 0? 1/2. Another way you can determine the absolute value, it is just simply the magnitude of the number, like 1/2 is 1/2 large. However, negative half would be made into positive 1/2. So the absolute value of negative 1/2 would still be 1/2. Some people think of absolute value as a shortcut anyways, is it just makes whatever number in the absolute value positive. So let me get back to the question. We're going to transform y is equal to x squared into y is equal to y is equal to 1/2 x squared. We're able to see A is equal to 1/2, therefore the absolute value of A is 1/2. The coefficient of interest is actually the absolute value of A, and that is 1/2. So the descriptor of this is we stretch by a factor of 1/2. Now that may not make sense. So we can also say we can vertically compress by a factor of 2. So I'm just going to take this point right here, and this point here is -2, 4. If I vertically stretch this by a factor of 1/2, it becomes -2, -2. That is, that point is compressed by a factor of 2. That's another way of saying it. -1 turns into, -1 turns into -1, 1/2. 0, 0 remains at 0, 0. 1, 1 turns into 1, -1/2. And 2, 4 becomes 2, 2. So look at what happened when our graph is stressed by a factor of 1/2. That the y values are actually shrunk down. In other words, the y values were compressed by a factor of 2. But you could also say they're stretched by a factor of 1/2, even though it doesn't appear like they're stretched. So point form, we can say I had graph y is equal to x squared, and those have points x, y. And then when I transformed them, and I introduce the absolute value of 1/2, which is 1/2, in front of the x squared, each and every one of my points, the x values stayed the same, but the y values were multiplied by 1/2. So whenever we're dealing with a vertical stretch or compression, we are looking at the absolute value of A. A very uninteresting case is when the absolute value of A is equal to 1. We don't do anything. But if the absolute value of A is different than 1, then simply what we do is we multiply y values by the absolute value of A.